Good morning, afternoon, or evening. How you doing today, guys? Welcome back to Mr. Morrow's Algebra 1 and 2 class. Today we're going to wrap up factoring, and it's very important because factoring is going to be used for many chapters, many applications of factoring. So today we're going to be factoring special cases and then just general factoring strategies we're going to go over, okay? We already know how to factor out a GCF. That's the first and foremost thing we always do. We know how to factor out trinomials where there is a 1 as the leading coefficient. We know how to factor out trinomials where there is a leading coefficient other than 1. And today we're going to learn special case or special products or special case factoring, however you want to call it. Okay, let's do this. First things first, my friends, we're going to talk about perfect squares. The good news. You saw this when you guys were multiplying binomials, if you remember. And I told you that if you have a plus b squared, that turns into a plus b times a plus b. And then when you went ahead and multiplied that, you would get a squared plus 2ab plus b squared. Let me show you how to work backwards today. When you are given a trinomial in the form where the first term is a perfect square. The second term is a perfect square. And the middle term is 2 times the square root of the first times the square root of the second. You're going to have what's called a perfect square, and it factors into a plus b squared. Same thing if you have a perfect square, but it's a subtraction. If I have a perfect square on the first term, perfect square is the last term, and my middle term is 2 times the square root of the first times the square root of the second, it factors out into a minus b squared. Now, what am I talking about? Let's say I give you 25x squared, let's say I have over here plus 4 and plus 10x. All right. Remember how I told you guys you got to know your perfect squares? This is the time to shine. Is this a perfect square? What is the square root of 25x squared? 5x. Is this a perfect square? What is the, wait, let's make this a 20. All right, sorry about that, guys. So, 25x squared I changed it to 20, sorry. 25x squared is a perfect square, the square root is 5x. Is 4 a perfect square? What's the square root? Okay, what's 5x times 2? Times 2? Is that the middle term? So does this meet the criteria of perfect square? So the answer is a plus b squared. Your a is the square root of the first term. Your b is the square root of the second term. If the middle term is 2 times the first times the second, you got a perfect square. Yes, sir. I don't multiply by 2 twice. I went first term a times second term b is 10x times 2 is 20, and that works. Yes, sir. No, it's a positive 4. Now, how about if I go 16x squared, and let's go plus 9, and let's do here minus 24x. Okay, let's see. Is 16x squared a perfect square? What's the square root of that? Is 9 a perfect square? What's the square root of that? What is 4x times 3 times 2? Times 2. 24, is that correct? So there's a minus here, so it's going to be 4x minus 3 squared. Does that make sense, guys? Yes? Okay, now, the good news. The good news, and I think this is great news. Mr. Morrow, what if I forget the formula? No big deal, do it the old way. Let's say we had, for example, 4x squared, and you have a 25 here, so it's plus 20x. Okay, ready? Oh my God, I forgot the formula. I don't know it. Oh my God. Oh wait, Cuban method. 4x, 4x. What's 4 times 25? What times what is 100, but when added together is 20? 10, 10, 10, 10. And actually, wait, no. Yeah, 10, 10. No, it's not negative, it's positive. Artificial factor, so I'm going to have 2x plus 5 squared, because they're both 2x plus 5. So worst case scenario, you don't need to memorize that. Isn't that great? That's a good thing. Yes, sir. If you FOIL 2x plus 5 times 2x plus 5, you'll get that. Yes. That's the whole point of checking, if you want to check. Does that make sense, guys? Okay. So that's perfect squares. We're going to practice. Don't worry about it. But that's perfect squares. Now, this one, I'm sorry. You have no choice. It's the way it goes. I'm sorry. I'm sorry. You have to do it. I'm sorry. There's no choice. I'm sorry. Have to memorize a difference of squares. But man, is it easy. If you have a perfect square minus another perfect square, okay, you're just going to take the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. And you are done. What am I talking about? 4x squared minus 9. Is 4x squared a perfect square? What's the square root of that? 2x. Is 9 a perfect square? What's the square root of that? Hey, did I have two perfect squares that were being subtracted? So it's the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Done. Bless you. Does that make sense? Easy peasy if you know how to recognize perfect squares. Sum of squares. Good news. You can't factor it. They're prime. So they'll try to put this on a quiz or on a test or on an SAT, and you know people will feverishly try to solve it. You're never going to get anywhere. It's prime. It's not factorable. Don't sweat it. If you see two perfect squares and they're being added, prime, next. It's a 2-second question. Now, difference of cubes and sum of cubes. Okay, please follow. When you have a perfect cube minus another perfect cube, okay, it is going to factor out the following way. The cube root of the first term minus the cube root of the second term times the cube root squared plus the cube root of the first times the cube root of the second plus the cube root of the second squared. So basically what you have to do here is right from the beginning, take the cube root of the first two terms, define your A and your B, and literally plug in the formula. Same thing for sum of cubes. If I have A cubed plus B cubed, that is going to equal A plus B times A squared minus AB plus B squared. Notice that when you have a difference of cubes, you have a minus here, but a plus all across on the other side. Notice that when you have a sum of cubes, you have a plus there, a plus here, a minus here, followed by a plus. Please be careful with that. Now, I see some of you looking at me like I'm talking in Chinese, so let's go x cubed plus 27. Okay, my friends. Is x cubed a perfect cube? Yes. As long as it's odd exponent, it's a perfect cube. Is 27 a perfect cube? Okay, so we can initiate the sum of cubes. First thing, let's find my A term. My A term is the cube root of x cubed. What's the cube root of x cubed, my brothers? X. My B is 27. What's the cube root of 27? 3. Now I have my A and my B, right, guys? And it's a plus here, right? So follow the formula. A plus B times A squared minus AB plus B squared. You're done. Have a good day. Bye-bye. Does that make sense, boys? Because now we're going to practice. What do you mean, where did I get the 9? I follow the formula. A squared minus A times B squared. Isn't B 3, man? So what's 3 squared? 9. Yes, you have to memorize the sum of squares. The sum of cubes, the difference of cubes, and the difference of squares. It helps if you memorize the perfect squares, but that one, as you already noticed, we can do the trick. The regular cubic method. All right, let's see what we got here. First of all, you could do this easy. What times what is 16? But when added together is 8. You could do that. Or you could recognize, wait a second. Is that a perfect square? What's the square root of that? Is that a perfect square? What's the square root of that? What's x times 4 times 2? 8x, it works. So this is x plus 4 squared. Or you could have gone the long way. What times what is 16, but when added together is 8. It's plus 4 plus 4. And doesn't x plus 4 times x plus 4 equal x plus 4 squared anyways? Does that make sense, guys? You promise? Okay. I'm going to get rid of that one for space. Okay, number 5. Is this a perfect square? What's the square root? Is this a perfect square? 100. What's the square root? 10. Okay, what's 10 times x times 2? 20. It works. So this is a minus here, so it's x minus 10 squared. You with me? Okay, is y squared a perfect square? Is 121 a perfect square? Are they being subtracted? Okay, so what's the square root of y squared? What's the square root of 121? So, square root of the first plus square root of the second times square root of the first minus square root of the second. Done. Difference of squares. Okay, over here, sorry, I'm going the wrong order here, but whatever. Number 2, is 9y squared a perfect square? What's the square root of that? Is 64 a perfect square? What's the square root of that? Are they being subtracted? So this is the difference of squares. Square root of the first plus square root of the second times square root of the first minus square root of the second. Done. Factored. Okay, number 6. 2 is not a perfect square, is it? But can I factor a GCF out of this? I can factor out a 2. So I have x squared minus 1 now. Is x squared a perfect square? What's the square root of that? Is 1 a perfect square? What's the square root of that? So are they being subtracted? So it's the difference of squares. Square root of the first plus square root of the second times square root of the first minus square root of the second. It's making sense, guys. This is flowing. Okay. This for this number 10. Not a good one for the cubic. Yes, sir. If you could not factor anything out of 6, it would have been considered prime. Yes, sir. For number 10, guys, we could do the cubic method, but it's going to be a very large new C. If we go 4 times 81, that's going to be 328. That's a very large C. So in this case, it's good to try to really understand the perfect square. Is 4y squared a perfect square? What's the square root of that? Okay. Is 81 a perfect square? What's the square root of that? Okay, what's 2 times 9 times 2? 36. Does this work? They're all pluses, so this is 2y plus 9 squared. Seriously, does that make it a lot easier? If you just know the format. Okay, this is a great one. You really want to multiply 36 and 25 and try to see what times what is that, but when added together is negative 60, that's a mission. Is 36x squared a perfect square? What's the square root? Is 25 a perfect square? What's the square root? Okay. What's 6 times 5 times 2? Does it work? There's a minus here, so the answer is going to be 6x minus 5 squared. Talk to me, guys. Are you seeing this? Okay. 4x squared plus 81. Is that a perfect square? 2x. Is that a perfect square? 9. Are they being subtracted or added? So this is prime. Sum of squares you cannot factor. Ooh, 27 and 12, those are not perfect squares. Can I factor anything out of that? What? A 3, very good. Giving me a 9x squared minus 4. Is 9x squared a perfect square? What is it? Is 4 a perfect square? Are two perfect squares being subtracted? So is the 3 GCF that I factored out times square root of the first plus square root of the second times square root of the first minus square root of the second. Okay, now your favorites, what you were fearing. Don't fear the cubes, guys. It is easy. Is this a perfect cube? Is that a perfect cube? Okay. So let's first find my first term, a. What's the cube root of ay cubed? 2y. That's my a. My b, what's the cube root of 27? 3. So guys, it's the formula. A minus b times a squared minus a times b plus b squared. Done. Done. Bye-bye, bye-bye, bye-bye. Done. Is x cubed a perfect square? I mean perfect cube, sorry. Yes. 64, is that a perfect cube? Okay, only one person said yes. You gotta know your perfect cubes. What's the cube root of x cubed? This is my a. X. My b is the cube root of 64. What's that? 4. So it's plus, so follow the formula. Oh, wait. Wait, this is wrong here. Go back to number 4. There's a negative here. That should be plus 6. No, it's not 12. It's AB. Look at the formula. Perfect square is 2AB. Perfect sum of cubes is AB. Okay. So I have a plus here. So this is going to be A plus B times A squared minus AB plus B squared. Done. Have a good day. Okay. Okay, number 12 is, first of all, they're both negative here. So what do you think I should do first of all? How do I make them positive? No, you can't multiply. There's not two sides here. You can't divide here because there's not two sides. You can factor out a negative 1, yes. So I got 125x cubed plus 729. Okay. What's the cube root of 125x cubed? 5. That's my a term. And no, it's 5x. It's 5x. What is the cube root of 729? 9. Very good. So I have a plus. So it's going to be my a plus b times a squared minus ab plus b squared. And you're done. Does that make sense, everybody? Yes, no, maybe, kind of, sort of. Okay. And now, last thing, just a little factoring strategy review. Whenever we're factoring, guys, you factor out the GCF if possible. If you have two terms, it's either a difference or sum of squares or a difference or sum of cubes. Remember, sum of squares you can't factor. If it's 3 terms, you factor the trinomial into 2 binomials. It's either going to have an a coefficient other than 1, or the coefficient is going to be 1. And then I gave you a couple examples here of what to do. For example here, I would factor out a 2. I got x squared minus 2x minus 24. Then what times what is negative 24? But when I add together is negative 2. X minus 6, x plus 4. Done. Bye-bye. Here, is this a perfect square? What's the square root of that? 5x. Is this a perfect square? Yes. What's the square root of that? 3y squared. Remember, guys, the square root of an even number, you divide the exponent by 2. So, are they being subtracted? So, there's a difference of squares. 5x plus 3y squared times 5x minus 3y squared. Okay? And these last four, where they have 4 terms, they're grouping. Try to factor something out. You could do these 2 on your own. Homework is valid. I will see you tomorrow. Hope you had a good day. Hope you learned a lot.